Two vaccine candidates for the novel coronavirus both made headlines recently due to some very positive efficacy data and promising timelines. Both of these vaccines employ a new type of antigen introduction that hasn't been used for vaccines before: mRNA. mRNA antigen introduction has the advantages of fast and relatively cheap production compared to some more traditional methods. I discussed the general principles of how Moderna's vaccine works in a prior video, and actually what I said there applies to Pfizer's too. One of the striking differences between these two vaccine candidates is the temperatures they need to be stored at before administration. Pfizer's vaccine needs to be stored around minus 70 degrees Celsius, which is colder than any temperature ever recorded outside of Antarctica. Moderna, on the other hand, reports that their vaccine is stable for storage and transport at minus 20 degrees, which is more like a normal freezer. So that begs the question, why does Pfizer's coronavirus vaccine need to be kept so much colder than Moderna's? Here's how it works. mRNA is used by our cells as a temporary messenger between the blueprints in our DNA and the proteins that our genes ultimately code for. Once the RNA has done its job, it is degraded fairly quickly by proteins called ribonucleases, or RNases for short. These proteins are everywhere, so when scientists work with RNA in a lab, they must store them at these super cold temperatures where RNases are less active. The same idea applies here. If we want to protect our mRNA vaccine from degradation, we need to keep it cold. But both of these candidates use mRNA, so why doesn't Moderna's need the deep freeze? The company reported that their RNA is encased in lipid nanoparticles. This is similar to the barrier that separates the inside and outside of our cells, and protects what's on the inside. In the same way, the lipid casing can protect the RNA from RNases, meaning that even though they are more active at the higher temperatures, the RNA is more protected.